Hello, everybody, and welcome to today's webcast. I'm sorry we're getting started a little late today. We had some technical difficulties, but we are ready to start now. Thank you all for holding on and staying with us. We're going to be discussing the top 5 must-haves in a CAM system. My name is Candis Spraul from Swoosh Technologies, and later we'll be joined by Matt Beisel, who's an application engineer here at Swoosh. Now, at Swoosh Technologies, we're a full solutions provider, meaning that we sell the software, but we also fully support and train in it. And really, we're essentially, we care about the customer, making sure that they're most efficient and that they get the most use and the best use out of their software. So first, let's go ahead and look at the agenda for today. We're going to start by talking about the 5 must-haves. We're going to briefly overview them, go in and look at the Siemens Advantage and how the software can address those top 5 must-haves and what it does, and actually see the software in action. And then I'm going to show you some ways that you can learn more about it, including events as well as further webinars that dive deeper into some of the issues that everybody faces. And as always, if you have any questions, feel free to use the questions panel on the side of your GoToMeeting panel. And we'll try to address all the questions at the end of the webinar. The top 5 must-haves. We start by talking about full associativity from the CAD model all the way to, your G code, from design through manufacturing. And we also want easy capture programming repetition, as well as the ability to use, downstream data applications such as quality. Now, a CAM system is always best if it's a truly scalable set of integrated solutions, while everything works together. And, it really is best to have a company that is a leader in the industry across many different industries. And they can there to improve the software, improve the support, and improve all the services that go with it. So it really is crucial to having, a company like that, behind your software and behind its capabilities. Everybody faces these from industry to industry. They're pretty general, challenges. And we're really looking to overcome inefficient processes. What this will do is accelerate production, allow you to take care of more business, get more orders in, and execute them. You also want to achieve reliability. You want to get it right the first time without having to go back and make changes. And then you want to increase throughput, which will help you to remain more competitive and keep that competitive advantage among your competitors. So now we're going to have Matt Beisel come in, and he's going to walk you through how a software solution such as NXCAM can address all of these challenges and meet those top 5 requirements.
Okay, well, thanks, Candis. And can you hear me okay?
Yes, we can hear you great.
Okay, that's great. So let's get started. Let's learn about the model-driven process. In NX, we call this the master model. Master model enables users to have a single model that is used for all downstream processes, from drafting, tool design, and assemblies, to NC and CMM programming and more. Product manufacturing information, PMI, drives automation of programming, inspection, and documentation. Workflows are done in parallel and concurrently, thus reducing manufacturing engineering time. All users and consumers of the information are kept up to date, seeing the latest progress and or changes in the work because of the full associativity of NX. Everyone's on the same page at the same time, looking at the same data always. There is no need to manage multiple copies of a design model or to use separate softwares for different work tasks. Engineering change orders are seamlessly handled. All documentation and programming is updated from the single driving master model. This factor alone saves time and money, eliminating the issues like the part was programmed to the correct revision, but it was rejected by inspection because their documentation was a revision behind. So how many times has this happened to you? This has happened to me in the past in industry of parts that I'm working on aren't the current revision, or downstream processes aren't using the most up-to-date information, so such as inspection data. Let's go ahead and take a look at what our customers say about master model of NX. This is Jim Sutton of Mino Tool and Mold, and he stated this about Master Model and NX. Master Model enables the design change to propagate through tool design into NC programming. It ensures accuracy through the entire assembling, knowing that the finished product is what the customer ordered. Here we see the master model in a workflow diagram. You can see that we start with a design model. This design model is used in many processes as shown here. In the next slide, I will show you a video from one of our manufacturing experts at Siemens, Brian Drebelbus. He will show us the model preparation and job setup portion that covers the concurrent workflow we see here.
Model preparation and job setup in NX. Here, you can import or design your CAD model. NX reads all common CAD formats. We're going to select the CATIA V5 format. It's just a Windows file open, and here we'll see as we convert and load the part directly into NX, seeing the CATIA model. From here, we're going to create a sketch plane and model the work holding and fixtures, creating the construction geometry that's used to build that fixture. We'll start with just a simple rectangle defining the outside border or the footprint or pad for the fixture. Again, with constraints and dimensions, you can size and shape the geometry as necessary. Here we're selecting the edges or features of the part that will be used to create the containment boundaries on the fixture. This ensures that the fixture will always be associative to the part geometry. You can create fully defined sketches using the CAD tools in NX, as here we're adding additional geometry defining our design. You can create geometric rules that also assist in your design. Here we'll make all these lines parallel to the other sides of the fixture. Modeling the base and the mounting plate of the fixture is simple. It's just in the context of the part. We just select the part, we'll select extrude, and we'll just pick a face onto the part. This would be the mating face where the fixture would align to the part. We'll then select the top area, creating the mounting plate for the part. From here, you could go ahead and add other fixture components to the part. Like here, we'll add a bolt, right, that will be used in our finished assembly fixture or our inspection fixture to do that. Again, you can add additional clamps and fixtures using assemblies and components. So here we'll turn these off, and we'll continue on with our design using synchronous modeling to create the stock model for the manufacture of this part. Here we'll select the entire part and close all of the hole openings on the part. Again, we'll then offset different regions and boundaries of the part, representing what the casting stock would be from an investment cast part. Here we'll see a synchronous modeling can directly edit all the imported CAD model data. We'll add stock to the boss areas, change the blend radiuses on the part, and remove some of the other features or defeature the part into that. Add draft angles, etc., and continue modeling the stock model of the part. Here we continue modeling the second fixture for the part. Again, a similar operation as the first, we'll just create our sketch for our part, defining the areas of the fixture we need to create. We'll select the edges of the geometry again to remain associative. There we select the geometry. You can see the ease of modeling with inside of NX to create the fixture. Here we will move some of the clamp components. You can again see the ease of the dynamic repositioning of components in NX. From there we will create the fixture setup drawings for the shop floor. Again, this becomes a vital important when jobs are created is to have this kind of documentation quickly, easily, and readily available associated to the part. Preparing product manufacturing information with PMI, again, is easy just by attaching the geometry the same as you would in any sketches or dimensioning onto the part and creating the drawing, thus defining the product manufacturing information and feature control frames. Here we see the finished drawing being created for the inspection operations. There we move into and you see a finished job preparation has been completed. In design model, 2 fixtures, 2 stock models, in-process drawings, inspection drawings, etc. Accelerate your production with NX.
We have just seen how NX is used to increase your manufacturing engineering throughput in the job setup and preparation and tasks we commonly use. Having the ability to create associative stage models and stock or casting models from the customer-supplied design data ensures reliability and confidence that you always have it right. The inspection, quality department, preparation, and fixture needs were handled, and process documentations and drawings produced all concurrently from one driven design source, enabling accuracy and communications throughout the job cycle. Let me tell you more about the master model workflow moving to CAM and CMM programming tasks. Here, the work that was done in job prep and setup is used by the programmer and or programming departments to apply the tool and inspection paths. Brian will show you this in action in our next video.
Programming the setups and operations in NX. Adding the part and the fixture to the CMM from our previous model preparation is fast and easy. Simply open the part and add it to the machine tool. Dynamically adjust the fixture components. Here we will align the clamp to the mounting holes on our CMM. You may use constraints to center this clamp on the table's hole position just by selecting the edges of the clamp and a hole position. Using the PMI automation begins by linking the PMI on the model to the part. We select the SPM 600 probe and we automatically recognize the feature.
And one thing I just wanted to jump in here is PMI means product manufacturing information. So just wanted to let you go as that.
There's the measurement dimensions and locations for the part. The inspection paths are also seen in the inspection navigator. We verify the inspection paths of our part with simulation, and to modify a path we simply double-click to change any of the settings. Here we'll look at the point set and change them from 8 points to a 6x6 grid. Fast and easy programming at NX CMM. Let's look at what CNC programming department has been doing while we were over in inspection. First, set up programming the part and the fixture is mounted to the machine. NXCAM machine simulation verifies the programming and the material removal. Here we see NXCAM simulation verifying our 2.5D volume-based milling. We'll continue on with additional program features with easy-to-use 5-axis milling contouring around the bosses of our part. We then go in and we can look at swivel milling in 5-axis of the boss lugs on the part. We'll continue on with additional operations with 3+2 milling and multi-axis support by finish profiling the rest of our part contours, thus completing the first setup of this side of the part. Additional hole milling is fast and efficient in programming inside of NXCAM. Next, we'll look at the second setup. The programming begins here with face milling in the second operation. Cut and rapid traverse across voids are all program options inside of NXCAM's toolpath. Material removal and verification is standard in NX. Pocket floor and cleanup and helical Z-level wall machining is shown here. Here we'll continue on with that boss, finishing the second boss, and then moving on again to finishing the holes in the second operation of our part. Rotating and repositioning to do the second one with our spiral helical hole milling. Hole milling continues on the rest of our part to completing our part until we do our outside contour with multi-axis contour profiling. Let's look at how post-processing is done in NX. Here we select the desired post-processor in the desired control format. Quickly and efficiently, NX creates the posted output. Let's take a look at how this posted output NX would be used in shop documentation. Shop documentation is standard in NXCAM, and we create HTML formats of each operation and operations sheet. Tooling sheets and operations sheets are also used in shop documentation. Again, a simple click and pick creates this documentation in seconds. The job is now ready to go to the shop floor.
At this point, the work is ready to enter the shop floor production phase. We have just seen a completed manufacturing, engineering, and programming workflow process completed. We have seen how NX technology enables fast throughput with automation, intelligent features, and a streamlined interface. All along the way, we use the resource of tooling, fixture, machining, and post-processor simulation libraries in NX. It is with this capability that NX captures and reuses your manufacturing knowledge and practices to drive your production with consistency of output and reliability that's right the first time. Here, Brian will use NX to simulate what will occur on the shop floor.
The part has been machined. Now it's time for the first article inspection process to begin. Let's look at what CMM programmer had completed while we were in the CNC department. You can see the inspection paths now have been selected and are completed. Any modifications made. We'll now go back and simulate what is happening on the shop floor inside of NX CMM. So here we'll see the inspection paths come down, do the locations for our holes on the side of our part, and then we'll be deprobing our rib and pocket locations. Again, you can see safe repositioning of the probe to measure the rib locations and thickness. The manufactured part is now completed, past inspection. You're in production now. All completed manufacturing cycles were done using NX. The weight, engineering change notice. How much time and effort will it cost you? Will there be to redo all the engineering and programming time on the first article production? ECOs with NX are an everyday challenge. It's simple, it's fast. We'll take a look at what has changed. We'll look at the hole locations, the rib locations, thickness, and corner blends all have changed. NX maintains the associativity of these updates and has updated all the documentation drawings and inspection drawings. The drawings you see have reflected all of these changes. Next, we'll review the impact the ECO has on the CNC programs. As you can see, we opened the part, and the part files in the Navigator have been marked invalid. They need to be updated. Changes to the toolpaths were marked. We select Generate, and the new processes are simply updated and used for your verification with simulation to approve their changes. We'll continue on looking at all these changes that are going on with our part. Next, the user will select and view the toolpaths of each maybe single operation he would like to review. We'll now look at what happened to the CMM program and verify those ECO changes. Again, we see the model has changed and the inspection paths. Again, we go back, use simulation to verify that, to have the confidence in knowing it was right the first time. Again, we will go back. You'll see the pocket and the rib locations have moved along with the thickness. Fast, efficient ECO handling with NX Manufacturing Solutions.
The Siemens Advantages. We just have seen the advantages of the model-driven process and how NX can decrease your time spent in manufacturing, engineering, and programming department, bringing consistency and confidence to your manufacturing workflow and processes. Next, we will look at NX CAM's innovative technology in toolpath and job programming. We'll see how productivity is increased through NX automation. Innovative technology in NX CAM. Toolpaths are created with optimum tool and cutting strategies to reduce programming time by eliminating lengthy geometry selection and preparations necessary in many CAM systems. Productivity is increased with intelligent toolpath generation by NX CAM's knowledge-driven tools. NX CAM's 2.5D volume milling saves programming time with built-in intelligence, resulting in not only programming time reductions, but time-saving material removal, all while keeping it up to date with the master model to give you even more time, saving power when an engineering change order comes up and tries to slow you down. Let me go ahead and show you how. Let's go ahead and look at an industry example. The company is Telsmith. The industry that they're in is industrial machinery and heavy equipment. Their business challenges are to increase CNC programming output and improve NC machine productivity. And the results from using NX-CAM are more CNC programs were generated in 3.5 months using NX-CAM than in 9 months using another CAM system. NX generates more programs in spite of being used to program more complex machines. And Michael Weir, a CNC programmer at Telesmith, said, "We measure our savings not in minutes or hours, but by the number of shifts that we save." Innovative technology. NX can increase your efficiency in turning, milling, drilling, multi-axis, CMM, documentation, etc. Many products need to be manufactured with multiple setups across multiple styles of machines. We have seen how master models ensures we have the correct data all the time. Now let me go ahead and show you in detail how NX-CAM can drive productivity and time saving to your business. The Siemens Advantages. Solution confidence. We have seen master model, NX-CAM, NX-CMM, shop floor documentation, all in a concurrent workflow, showing how innovative NX technology can enable your business to grow and be more competitive. Let me show you in more detail how Siemens Manufacturing Solutions are affordable, right-sized solution for your business. The 3 major components that contribute to manufacturing reliability and confidence that make it so you get it right the first time are an integrative, associative manufacturing environment. This brings it all together from CAD, CAM, CMM to the shop floor. Scalable solutions to match your business needs at an affordable cost. Let us go ahead and show you how affordable an NX solution is. You can start with value price packaging or point solution for turning or milling, etc., and always have the confidence that you can add capabilities as you grow and your needs change, all the way to a fully managed manufacturing shop floor simulation environment. Also, staying power of a major manufacturer, such as Siemens, which is an established leader in the manufacturing market. Let's look at an example of a company that uses all the Siemens product solutions. Fook leverages end-to-end product development solution from Siemens PLM software to streamline development of large, complex machines. The solution includes NX, NX CAD, NX CAM, Team Center, Siemens 840D controller are installed on the machines on the floor. Whether your company's small, medium, or worldwide manufacturer, Siemens manufactures solutions that is the right size for your business and the future. And Hans-Jürgen Pierik of Fook GmbH has this to say about Siemens. The integration of the Siemens system is what brings the benefits. Let's go ahead and watch and listen to what one of our mold and tool companies has to say about their success with NX.
Menco Tool & Mold's primary business is building plastic injection molds. We've been in business for over 50 years. Our competition isn't the company down the street. Our competition is the world marketplace. We were an early entrant into CAD-CAM, where we found a niche in the marketplace, whether it be just general machining or it be in the mold making part of our business. It is complex shapes.
We always strive ourselves in the quality of the tool that we take to press. We use NX to maintain that quality. A customer comes in with a concept sketch that he wants to manufacture, he wants us to mold. We're able to take that napkin sketch, turn it into real product using NX. NX gives us the tools to engineer our designs up front, whether it be a product design or a tool design. We want to make sure that we go through all aspects of the part and the tool early on in the process. By doing that, we know that when we start cutting chips that we're actually cutting what we want. We're not duplicating efforts. So it's important for us to maintain that accuracy through the entire process, and that's what NX gives us.
We get a supply file from a customer, and we'll take it in here and we'll redraft it and make it toolable. Basically, I will wrap steel around that part and make the mold base that will produce the plastic part.
NX is a strong modeler where we can bring in data from multiple sources. The ability to manipulate complex geometry is easier to do inside of NX because its ability to deal with explicit models, hybrid models, or fully featured models. We're not limited by the software in order to develop our product.
Synchronous technology helps in the way you can manipulate geometry easily. You can go in there and remove faces, delete faces, simplify bodies quickly. You don't have to worry about parameters. You just go in there and delete or change size. That is a Mold Wizard component. We dropped that in. It automatically knew to hook into the ejector plates down here. All we did was put the part area on it by wavelinking in the part geometry into the lifter file and then trimming it off. And if we ever update that part, that lifter will update automatically.
We allow that master model then to propagate through the tool design into programming, where tool design will go in, update their model. Programming then will go in and update their data, their tool paths over top of the existing tool data. That's going to ensure that we keep accuracy through the entire assembly, knowing that the finished product we get out of the mold will in fact be what the customer initially sends.
We program 100% of the model using the CAM software from NX, and then we do all our trode modeling, everything through NX, so the finished product. The master model is very important because if everybody's on the same part at the same time using the same model, everybody's looking at the same thing all the time. Everybody knows how to dimension, verify stuff. You don't have to teach 3 or 4 different softwares. So if it's everybody synchronized on the same software, everybody can help each other. You got to save time, you got to save money, so we implement the high-speed machining whenever possible, small cuts, light cuts at fast feed rates. And yes, NX has several options that you can adjust your paths accordingly. There's options in NX that will actually turn the corners, which actually creates a much nicer and smoother path. It doesn't have the jerkiness of the machine.
It's faster, it's better quality. Now you just set it up and away you go. Sometimes you may have 12, 14 inches, and now we can cut that in half, which means better rigidity, better part finish, better tool life. Sometimes I'll run 20, 24 hours for a finish cover that requires no polish. And you have to have a very good software to do that. We start in product with NX, we design in NX, we program in NX. So what you see is what you got. I mean, that's just that accurate, it's that good. And without it, we wouldn't be in business. I mean, that's pure and simple. I mean, if you're not your guy cutting fast, you're not making money. If you really want to cut a true part form and cut it accurate, you better have it all today, because the pricing isn't there anymore. It's a world market. It's serious business.
NX is an important product to us because it is an integrated product, and that's what we're about. We don't just design the part, we manufacture the part. So it's important to us to take it all the way through in the same software.
If we maintain accuracy both from product design, tool design, programming, through the building of the tool, we're going to ensure that we maintain a level of accuracy that gives us a high quality part.
Time and cost somewhat equate. If you can't beat them on labor cost, then you've got to find a way to beat them in some other way. And that's where we excel and always have excelled, is that not only do we do things in a hurry, but we do it on time.
Thanks, Matt. So we talked through all of the Siemens advantages from the model-driven processes, innovative technology, and solution confidence. And hopefully you all paid attention and realized just how much of those top 5 must-haves in a CAM system that NX CAM contains. So there's different ways that you can go on and you can learn more about all of these. You will be having 3 follow-up webinars, every 2 weeks. I will send you links to all of these. But the first one, we're going to be covering CAM programming and automation. The second one, we're going to talk about probing and quality. And the third one, machine tool verification. So feel free to sign up for all three or just one or two, whichever pertains to your needs and your business issues at hand. And then we also have another event for those of you in the Northeast, and that is a CAM workshop at CCAT, which is the Connecticut Center for Advanced Technology. It's a 3-day workshop, and what we do is we have you bring in any of your NX or any of your CAM issues, whether NX or not, and you come in and you sit with our experts as well as some from CCAT and Sandvik and third wave systems, and we troubleshoot your issues. We use whatever software is there. They have a full machining center, and everybody just comes together, works through their issues, increases, your production, maybe just increases your efficiencies, and it's really going to be a collaborative environment. So look out for the invitation to that as well, and a chance to register for that. And to end it, I wanted to go ahead and give you all my information in case you have any problems. Feel free to, or any problems or questions, feel free to, email me or give us a call, and I will point you in the right direction so we can answer any of your concerns or questions. And it doesn't look like we had any questions come through during the presentation. Oh, we did. Let's see. Does the inspection module have a machine link, or is the CMM code posted out too?
Okay, so that question, as I kind of understand it, is the inspection program inside of NX, it uses DEMIS standard code. And so just like kind of on the machine tool you saw, the post-processing, we also have post-processors that are for your individual CMM. So we, have a wide variety from the major manufacturers of, post-processors. And additionally, there's also, a direct link for the actual program itself. The actual program is associative. So as I change, the design model, or if I change PMI information, the product manufacturing information, like the specific location of something, a radius, whatever, when upstream the CAD data changes, downstream it's going to say, well, there's something wrong. And so what you do is you just go ahead and regenerate the information, and it's all associative. You have, your updated CAM program or CMM program.
All right.
Does that, any other questions?
That is the only question that came through. And like I said, if there are any more come up, anyone feel free to, give us a shout out, give us a call. We also have a form on our website. If you go to www.swooshcheck.com, that if you think of anything in the future, you lose our contact information, go on there. There's an Ask a Question link, and fill it out, and we'll make sure we address anything. So thanks, everybody, for coming today. Happy first day of spring. Hopefully it's warm wherever you are, and enjoy the weather. Thanks. Bye.